Warp speed propulsion and wormhole formation. In the vast silence of the cosmos, we are taught to see space as empty, a dark void, a stage where stars burn and galaxies drift. But what if this is an illusion? What if space itself is alive, a structured field, a fluid fabric that can ripple, bend, and resonate like an ocean? The cosmic clock matrix suggests that mass and space are not separate, but two halves of the same rhythm. Matter carries positive energy. Space carries negative energy. Together, they balance at zero. A cosmic equilibrium that cycles endlessly: expansion, contraction, renewal. If space is a quantum superfluid, then it is not static. It is compressible, oscillatory, and responsive. It can be shaped. It can be tuned. And if it can be tuned, then some of the greatest dreams of physics, warp speed, propulsion, and traversable. Wormholes move from fantasy to engineering challenge. A wormhole in this vision is not a random tear in reality. It is a controlled topological shift, like a bubble forming in a fluid under pressure. With the right conditions, perhaps through magnetic stress, vibrational resonance, or high-energy pulses, such a gateway could be triggered, stabilized, and used to travel across space or even between dimensions. Warp travel, too, is reimagined. A ship does not accelerate in the conventional sense. Instead, it sculpts the space around it. Compressing the fabric ahead, expanding the field behind, the vessel rides a wave in the medium itself. Inertia disappears. Time dilation fades. The ship does not break the cosmic speed limit. It flows with the rhythm of spacetime. To explore these ideas, laboratories become miniature universes. Bose-Einstein condensates act as superfluid analogs of space, cooled to near absolute zero, so quantum behavior is visible on a macroscopic scale. Superconducting magnets create intense gradients that mimic curvature. Femtosecond lasers inject ultrafast pulses to stir the medium, setting up oscillations that mirror cosmic rhythms. Interferometers measure bending of light. Atomic clocks listen for temporal drift. If the hypothesis is correct, subtle but profound signs may emerge: resonant amplification when the drive matches the frequency of the space-time fabric, light paths bending without mass, time drifting slightly out of sync. Even within condensates, transient voids or density bridges may appear laboratory-scale analogs of wormhole throats. These experiments would be the first step toward engineering the fabric of reality. Success would mean not only theoretical confirmation, but technological transformation. Wormholes could become traversable corridors, linking distant points in the galaxy. Warp drives could carry vessels across the stars without consuming impossible amounts of fuel. Artificial gravity fields could be created for spacecraft and orbital colonies. Even time itself could be modulated, slowed, accelerated, or suspended. This vision does not abandon physics, it builds upon it. Einstein's relativity still shapes the geometry of spacetime. Quantum mechanics still governs fluctuations and coherence. Fluid dynamics still describes compression, resonance, and flow. Thermodynamics still defines entropy and phase transitions. What changes is perspective. Space is no longer a backdrop, but a medium. A field that can be played, resonated with, engineered. The cosmic clock matrix reframes wormholes and warp drives not as violations of physical law, but as consequences of a rhythmic, oscillatory universe. If validated, the Big Bang is no longer a singular beginning, but one pulse in an eternal cycle. Spacetime is no longer a void, but an ocean we may one day learn to navigate. And so the dream of interstellar travel moves closer. The challenge is not to outrun light, but to align with the hidden frequency of the cosmos, to ride the heartbeat of space itself. The question is no longer whether such journeys are possible, but whether humanity is ready to shape the song of the universe and step through the gateways it offers.